Now I want to take a little bit more involved example with adding and subtracting rational expressions. In this case, we're going to take rational expressions that have different denominators. And as you recall, with fractions, when the denominators are different, it requires additional steps because we can't add these fractions, for example, 2/3 and 3/4, unless they have the same denominator. Here, I think it's fairly easy to see that if we just multiply these two factors together, we'll have a common denominator, which should be 12. So you want to take 2/3 and rewrite it as 12ths. So the way I like to think is I'm going to multiply this fraction by, in order to get 12 in the denominator, I'm going to have to multiply the 3 by 4. And so I'm also going to have to multiply the numerator by 4, and I'll end up with 2 times 4 is 8 over 3 times 4 is 12. So this will be 8/12. So I'll change the 2/3 to 8/12. And then take your 3/4, and I'll do a similar thing. In order to get 12 in the denominator, I'm going to have to multiply by 3. But in order to keep the value of the fraction the same, I have to multiply the numerator by 3. And so I'll end up with 9/12. Then we add. 8 plus 9 is 17. And the denominator stays the same as 12. So that would be the addition of those two fractions. Here, there are no common factors between the numerator and denominator, so that would be the simplest form. Okay, let's take an example with rational expressions, and we have variables in here. Here again, we need a common denominator in order to add these fractions. So we want to rewrite this fraction with the same denominator as that fraction. Here, we have x plus 1 is the only factor there, x minus 1 is the only factor here. So a common denominator, we can find a similar way to this. We multiply the two denominators together. So the common denominator, I'll just abbreviate it, is going to be x plus 1 times x minus 1. And you can multiply that out, it'd be x squared minus 1, but let's leave it in the factored form. And most of these problems, that's what we'll do, is leave it in the factored form. Okay, now I want to be able to express this fraction with that denominator. Let's use the same method we did up here. I'm going to take 3 over x plus 1 and change it so that now it has this denominator. In order to do that, I'm going to have to multiply the denominator by, looks like x minus 1. But in order to keep the value of this fraction the same, I'm going to have to multiply the numerator by x minus 1. So what we end up with is 3 times x minus 1 over x plus 1 times x minus 1. All right, so I'll rewrite that fraction. Like that. Let's take this fraction, 5 over x minus 1. Again, I want to end up with this denominator, so I'm going to have to multiply this denominator by x plus 1 in this case. And then to keep it the same value, I'll have to multiply the numerator by that. And what I end up with is 5 times x plus 1. In the numerator, the denominator, I'll have the same denominator, x plus 1 times x minus 1. So let's rewrite the second fraction like that. We have 5 times x plus 1 over x plus 1 times x minus 1. Okay, now we have the same denominator. We can continue to work with simplifying or putting these two fractions together. All right, we're adding the numerator, so this will be the same as 3 times x minus 1 plus 5 times x plus 1 over this denominator. So all I did there was add the numerators. Of course, you want to simplify the numerator, so let's multiply that out, and we'll have 3x minus 3 plus 5x plus 5, and we still have the same denominator. I'll move over this way. Let's simplify this. I'm going to get, it looks like 8x plus 2, again over the same denominator. And at this point, you should try to simplify it. So I would factor the numerator. It looks like it has 2 as a common factor. 2 times 4x plus 1. Of course, I bring the denominator down. And there are, even after factoring it, there are no common factors in the numerator and denominator. So you could leave it like this as your answer, or this is really the same thing, so either one. And we're done.